8:50 on the 5th of May, Monday at 2025. You are getting a fairly sharp view, although you can see some oscillation of the limb of the moon. Of the moon at 150x is what I'm calling it anyway. It's actually quite present on the screen for our viewing pleasure. Um, I went out with binoculars today just to confirm, and I'm not sure what I said last night, but this is the south, and this is the actual south because there was some weirdness in position angles like last night. Obviously, the west of the moon is here where you can see the limb, and the east is off where at the terminator. But I do know that this lobster shape here of the various mare tranquillitatis, etc., serenitatis, is facing in the general direction of the south, where the lunar surface is mottled with craters. So let's begin with that. So we're going to call this south, this is north, and I believe that's what we had last night. Here is the east and here is the west. I do believe things lined up pretty good last night. Tonight we are going to go through a set of 12 galaxies, making a set of 42, the answer to the riddle of the Hitchhiker's Guide to the Universe, which is, in this case, the answer 42 represents 42 galaxies that we will be observing using possibly a variety of exposure times this evening to get definitive views. So it's not quite sky dark. I don't expect the complete drainage of color, blue color from the sky, because the moon is pretty much hanging due south and slightly west at this point, and it is a 8-day moon. Well, it's now 9:29. The moon is dominating the skies, and I've been playing for the last half an hour or so with exposure times. And the only way I can reveal galaxies in the range of a 6-inch scope is to go to 1 second exposure times and then adjust the histogram to reveal them. This is a galaxy from last night's first 30. It's NGC 4045, a galaxy in Virgo. It's also known as NGC 4046. It's magnitude 12, 3.1 by 1.9 arc minutes. So it's probably got an average surface brightness greater than 13 and an average of about 12.75. It's an S lowercase ba. Lowercase ba means it's got multiple rings, multiple spiral arms. This one happens to have a ring. It's at 88 million light years, right ascension 12 hours, 2 minutes, 42 seconds, plus 1 degree, 58 minutes, 36 seconds. I do believe you can see the galaxy right here. I can play with the histogram a little bit, but I've already ended this for a minute. But since we only have 12 galaxies we have to go through tonight, I think you might want to see what I can do with eliminating some of the lunacy spoilage of the screen. I think I'll leave it at that one, and we'll go on to our first galaxy of the evening. I will attempt to do a half-second exposures and maybe even briefer later if we can actually see anything on the screen whatsoever. Okay, we've gone very far north to 43 degrees plus. For NGC 4111, a galaxy in Canis Venatici, magnitude 10.7, 4.6 by 1 arc minute, 42 million light years distant, so about 75,000 light years in diameter. Right ascension 12 hours, 7 minutes, 3 seconds, and declination plus 43 degrees, 3 minutes, and 56 seconds. Let's go ahead and pause and let's see if we can reduce this to a half-second exposure time and see anything of it at all. Well, now we're seeing the core region with some extension as a bar, although this is rated as a spiral of a lowercase a. So we're getting a little bit of an extension of the core right here. And that's about what we might expect out of a galaxy. So half-second exposure time is probably giving us more realistic views than 1 full second. And we will stay with this for the rest of the 12 galaxies in the series tonight to complete the Hitchhiker's Guide equals 42 galaxies. we're back up to the north again, and I've noticed as we go north that studies tend to drift in this direction in the 50% e-zoom field. This is probably the very core of NGC 4138, Galaxy in Canis Venatici, magnitude 11.3, 2.9 by 1.8 arc minutes, means it's probably somewhere around 13.5 or slightly less average surface brightness. This is a spiral with a lowercase a, 45 million light years distant, which means it's fairly small, somewhere in the range of 40 to 50,000 light years in diameter. It has a right ascension of 12 hours, 9 minutes, 29 seconds, and a declination of plus 43 degrees, 41 minutes, and 6 seconds. Let's have a look at 1 second exposure. Clearly, we can see in the same part of the field more of the extended core region of NGC 4138 by doubling the exposure time and adding the 0.8 magnitudes you would get by looking averted at this study in the eyepiece. All right, this time I thought we would start with a 10-second exposure of NGC 4143. So we can get an idea of where it is located. Unfortunately, I fell down on the job by not putting 4143 back in to the go-to so I could read the data to you. But that's a fairly striking look. And all that luminosity on the screen, yep, that's the moon. That's the lunacy at work. NGC 4143 is a galaxy in Canis Venatici, magnitude 10.6, a bit largish, 2.9 by 1.9 arc minutes, spiral with a bar, 48 million light years distant, makes it about 40 to 50,000 light years in diameter, right ascension 12 hours, 9 minutes, 36 seconds, with a positive declination of 42 degrees, 32 minutes, and 3 seconds. Now we're going to drop down to a 5-second exposure. Remember where it's at. Here's our 5-second exposure. So it's not sucking in as much moonlight. I have not changed the histogram settings of NGC 4143. And notice we are not observing it at higher magnifications. So I won't do that until we get down to 2 seconds so we can see where it ends up on the screen. All right, we're now on down to our 2-second exposure of NGC 4143 against a darker background sky, but with not as much presence because we are also losing a lot of luminosity in the galaxy itself. I'm going to push this up to 50% view. Actually quite nice. Core region with extensions going off towards the south and the east and the north and the west. Now let's drop it down to a 1-second exposure. Here's our low power view of the 1-second exposure. Just the core with hints of extensions going off. And if I zoom in at 50%, we're seeing a little bit more of the extensions. Let's go head on down to 0.5 seconds now. Right now, we're looking at our nominal 6-inch view exposure time of 0.5 seconds. We are seeing the faintish core, but it is still quite present on the screen. Once again, we're looking at NGC 4143, magnitude 10.6, 2.9 by 1.9 arc minutes, meaning it has about 13th magnitude average surface brightness, spiral with a bar, but it's also a lenticular, so a very mature galaxy. 48 million light years distance at right ascension, 12 hours, 9 minutes, 36 seconds, declination of 42 degrees, 32 minutes, and 3 seconds. One more step. We're going to go down to 0.2 seconds in terms of our exposure time. Well, at 0.2 seconds, I can just barely hold the core direct. It brightens a little bit. Remember, once again, this is 50% e-zoom. It brightens a little bit on extension. It's kind of hard to say whether there's anything on eye movement, however. It's just too faint. There's not enough residual texture in the galaxy to reveal much. But we are seeing this magnitude 10.6, roughly 13th magnitude average surface brightness, NGC 4143, 2.9 by 1.9 arc minutes. You'll get more details on the screen as text in the manana. Here we're going to start at 0.2 seconds exposure time. For NGC 4150, a galaxy in Coma Berenices, so it's about 30 degrees from the 8-day moon. 4150 is magnitude 11.6, 2.3 by 1.6 arc minutes, so it's probably got about a 13.5 magnitude average surface brightness. This is a lenticular spiral. Typically, the difference between their invisible light, blue-violet, and visible light is about a magnitude. That's a common characteristics of lenticulars. 45 million light years distant puts it at about 40,000 light years in diameter. We're at a right ascension 12 hours, 10 minutes, 33 seconds with a declination of plus 30 degrees, 24 minutes, and 6 seconds. Let's push this up now in the other direction to 0.5 second exposure time. Well, here at the tip of my pointer is once again NGC 4150, that 11.6 magnitude galaxy in Coma Berenices, quite clearly present at 0.5 seconds exposure time, which I do believe approximates to a 6-inch eyepiece view of the scope at 150x. Well, just for an experiment, I've gone and exposed NGC 4150 for 10 seconds exposure time. Brilliant core with core extensions going off to the southeast and northwest. But very luminous field, and I haven't touched the histogram for this at all. So it looks like I've dialed them in pretty well for being able to range across the various exposure time continuum. Well, folks, this is what you'd see through a 24-inch scope at 150x on a 8-day night, pointing a scope within some 25 degrees of that 8-day moon. This is NGC 4189, galaxy in lower southern Coma Berenices. Its magnitude 11.7, 2.5 by 1.7 arc minutes, spiral with a bar and lowercase c, so it's an undeveloped galaxy, but you can see it's relatively face-on, and it has a circular aura around it. Could possibly even be a ringed galaxy, although that is not indicated here. Spiral with a bar and a lowercase c, 84 million light years distant, so, intermediate size, maybe 50,000 light years. Right ascension in 12 hours, 13 minutes, 47 seconds, with a declination of plus 13 degrees, 25 minutes, and 29 seconds. We are about to flip to the other extreme. Here we have NGC 4189 again, and I'm going to have to mark where it was, but there's a faint, about a vague luminosity here and a brighter star there. We're not finding any matched triangles, so we can't do any real stacking. So this is a single pass pretty much at 0.5 seconds. And I would say basically it's pretty useless to use stacking imaging when they can't find the matched triangles because they have no way of overlaying it. We're basically just getting a single pass at this point because the moon is basically hollowing out the night sky for star content. At 0.5 seconds exposure time, we are getting some triangulation because it says current image. Oh, it's saying cannot find. But we're getting a nice flat field. We're not getting a lot of pixelation, which is one of the nice features of ASI Live. What you're seeing here is a half a second exposure of NGC 4203. It's magnitude 10.9, so that core is nice and bright and present there. But it's also quite large, 3.5 by 3.2 arc minutes, spiral of the lenticular class with a bar. 50 million light years distant puts this one at about 60,000 light years in diameter. I am sure Steve Gottlieb will mention this brightish, probably 7th magnitude star in the same field, probably no more than 5 to 6 arc minutes distant. We're at right ascension 12 hours, 15 minutes, 5 seconds, declination of plus 33 degrees, 11 minutes, and 50 seconds. Well, our next study is NGC 4212, another galaxy in Coma Berenices. It's also 4208, which we may have already imaged, but I don't think so. It's magnitude 11.2, 3.2 by 2 arc minutes, spiral with a lowercase c, 61 million light years distant. Right ascension 12 hours, 15 minutes, 39 seconds with a declination of plus 13 degrees, 54 minutes and 5 seconds. I think we should take a look at this at least a 1 second exposure time just to reveal where it is on the screen. Well, I did say at least a 1 second exposure. This is actually a 0.5 seconds exposure. Very luminous background sky due to the moon. Not a lot of bad pixelation, however. Other galaxies in the field. Look at this beautiful edge on right here. Boy. So you can do some serious observing during the lunacy if you're using an imaging system. However, you are going to have to put up with the fact that you do not have a nice black background sky. Well, I did pump this one up because I'll tell you why. You can guess. NGC 4237 at 10-second exposure time is a galaxy in Gamma Berenices. Magnitude 11.6, 2.1 by 1.4 arc minutes, spiral with a bar, lowercase bc, so 2.5 times removed from lenticular. It has a ring to it. 54 million light years distant puts this at about 35,000 light years in diameter. I think you can make out the fact that it isn't a newer galaxy simply because the shape is so well defined at its borders. So let's drop it back down to something more reasonable, like a half a second. Well, at half a second, I guess if you look averted, you might just make out 11.6 magnitude NGC 4237 in Gamma Berenices. It's 2.1 by 1.4 arc minutes, so it's probably somewhere around 13.5 average surface brightness, so it is in the averted range. If you look where I'm putting my pointer right there, you should see the core of the galaxy with a little luminosity about it. This is at 0.5 seconds exposure time, which approximates to a 6-inch scope at the eyepiece, in this case 150x. Well, the galaxy you're seeing here is not part of my list for the evening. It may be magnitude 10.4, but its average surface brightness is going to be somewhere around 14 to 15, which is outside my parameters for a 6-inch scope. The reason I'm showing it is because it's spectacularly edge-on. It's NGC 4244. We are looking at a 10-second exposure time, a galaxy in Canis Venatici, 10.4, 15.9 by 1.8 arc minutes, spiral of the class C, and you can see why it's a C. It only has a star-like core. Anyway, 12.4 million light years distant puts this probably somewhere around 70,000 light years in diameter, despite the apparent size. We're at right ascension 12 hours, 17 minutes, 29 seconds with a declination of 37 degrees, 48 minutes and 25 seconds. Get out those 12-inch scopes and have a look at this baby. Well, it's been about 5 minutes. We're back at NGC 4244, that beautiful edge-on galaxy. I'm doing 30-second exposures right now. And the only reason I'm doing this, well, besides the fact it's such a spectacular edge-on galaxy, is the fact that the scope wanted to do an equatorial flip before I go on to my last 2 studies of the evening. So I thought we might want to share this beautiful edge-on galaxy, NGC 4244, with several stacks of 30-second exposure times. This baby is giving us, if we didn't have the luminosity of the moon, we would be getting images, I believe, that are comparable to the digitized sky survey. 30-second images, multiple stacked. Very, very beautiful. I can see why imagers such as my own son Christopher would take the time to get off-axis guiders, etc., and do multi-stacking 10-minute video movie images just to create a composite image that looks similar but many times better than the one you're seeing now. And of course, when you reduce the exposure time to 2 seconds, that galaxy doesn't even exist. Well, here's our not view of NGC 4245, galaxy in Gamma Berenices, magnitude 11.4. The reason we're not seeing it is it's very large, 3.3 by 2.4 arc minute spiral with a bar of a lenticular class tending to the A side, so half removed. It has a ring, 34 million light years distant, puts this maybe at about 40,000 light years in diameter. We have 2 more galaxies to do after this, so why don't we just take a moment and then see if we can get a good view at 5-second exposure time. This is a 2-second exposure time image, by the way. Okay, I left the imaging system running, or should I say the Microsoft snipping function. We're now having a look at NGC 4251. We had a crazy star move across as it navigated. This is 4251. It's supposed to have a ring. I'm going to pause it for a second. Here we have a 10-second exposure of NGC 4251, that galaxy in Coma Berenices, magnitude 10.7, 3.6 by 2.5 arc minutes, spiral with a bar, lowercase o, and a ring, 44 million light years distant. Right ascension, 12 hours, 18 minutes, 8 seconds, with a declination of plus 28 degrees, 10 minutes, and 29 seconds. Let's pause and have that view at 1 second or 0.5 second exposure time. Well, I must say that is probably just the very brightest core of NGC 4251, but it is also about a 13.5 absolute average surface brightness galaxy, which can be quite problematic. Its core is probably somewhere around magnitude 11.5. We have a moon up. I'm using 0.5 second exposure time, which gives us the approximate view of a 6-inch scope on a good night of seeing. NGC 4254 is our last study of the evening. We're operating at 0.5 seconds exposure time. The scope is probably some 25 to 30 degrees pointed away from an 8-day moon. We're not getting any kind of view that I can tell of this one. There may be some faint haze right about there. Let's increase the exposure time to 1 second. I discovered that by playing with the histogram, I could get that 0.5 second view of NGC 4255. And there we have it on the screen. Let's have a look at 1 second, and I'll give you some data. All right, here's the data on NGC 4254. It's a galaxy in Coma Berenices, magnitude 9.9, 5.3 by 4.6 arc minutes. It is a spiral of class C, which means rather diffuse core and probably lots of current star formation going on there. The galaxy is 67 million light years distant, which puts it at something around 100,000 light years in diameter, slightly larger than our own Milky Way. Its right ascension is 12 hours, 18 minutes, 49 seconds, with a declination of plus 14 degrees, 25 minutes, and a second. You might say, well, a galaxy 9.9 and relatively smaller than many of that magnitude, it must be a Messier, and you are correct. Charles Messier or Messier discovered it in this mid to late 1700s. I do believe Messier 99 is one of the brightest, faintest Messiers, however. Let's have a look as a Carpe Noctem view at 10 seconds. Here we have our 10-second view of Messier 99. You can see it's got nice spiraling arms going off the core region with spiral arms. There are several, 1, 2, 3, quite visible. I could play with the histogram. I'm a little concerned that sometimes when we get to 25 minutes or so, I lose part of my video with the snipping tool, but we just gotta have that look. Carpe.